Hello, everyone. Once again, I'm going to quickly share my screen so that we can have a look at what we intend to cover. So, yeah. So last week we covered this section. We covered how to log into our database, how to create schemas, how to create tables under the schemas. And then we went ahead to, ingest data into the database from our desktop. Uh, yeah, we created a table and then we ingest data to it. So we also created another table called consumers, and then we also ingest the consumer complaint data into it. So today we are going to briefly query it. And after we query it, we're now going to basic aggregation, which will lead us to, ingesting another data for basic aggregation because um, the consumer complaint data doesn't really support that. So yeah, uh, now let's log into our database, okay? And to do that, we have to do this. Open a window, go to local disk, and then go to program files, go to uh we'll find Postgres. Is it here? Yes. Okay, yeah, Postgres. And then we'll go to 13. Yeah, so this way okay, go to bin. This way we're going to. So when we get there, we click on this. You can see where I place my cursor. You click on it. So when you click on it, you copy the address. So the next thing we'll do is to type terminal. That's the command prompt. You can see command prompt here. So you can open it as an administrator, right? Okay. So once we do, we can just say cd. This is the address, the directory we copied just now. So we do that. So we are now in that directory. We can now try to log in. Remember our login command is psql -h, which is the host 127.0.0.1 dash u. This u is capital U for the user. The default user we are making use of is Postgres. And then you hit enter, and this should prompt for password. We will now type the password, and that's it. We are in. So this shouldn't be difficult for you to log in by now, right? Because we've demonstrated it in the last session. So what we are now going to do is to, practice statements and clauses. And yeah, for this one, we can, okay. So I'm going to increase the size. So basically, I don't know if I demonstrated this the other time, but let's see. So when we want to fetch from all the table, for instance, the issue table, what we'll do is use select. The asterisk is indicating that we are selecting all the columns. Okay. So we are going to use asterisk. So I'm going to type that, right? So we'll do select asterisk from issues, but I mean, this is Postgres, right? You have to tie the table to the schema. So you say my schema dot issues. Issues is the name of a table, right? Let me see. It says schema relation does not exist. Okay, maybe it's not with X. I don't know. Let me see. Yeah, it's not with X at my end. Now, you can see that it tries to pull everything in. If you hit enter, it will continue to bring in more rows. As you press the enter button, it continue to bring in more rows. So you use Control C to break out of it. Okay. Now, but we can run the same command and then put a limit to it. Limit in this case helps you to, you know, define the number of rows you want to see. I can say limit 15. You hit enter, and then it will pull 15 rows out for me to have a look at. So this is basically how you pull all the columns. However, it is not ideal. Not ideal because okay, let's still do this one more time. Let's just pull 5 rows. So it's trying to pull 5 rows. You see, this is 5 rows. Uh, it is not ideal because when you are working on a database that is hosted on cloud, most likely you will be charged per query. I'm talking about database engine or an analytical database engine like Athena, like BigQuery. You are going to be charged by the service provider based on the amount of query you the amount of that is the amount of query you are placing, right? So how many retriever are you doing? That's we define how much you will pay. So what I simply mean by that is that you have to define the number of columns you want to see, and then in most cases the number of rows you also want to see. You don't need to pull all the rows, except when you just want to, do that for maybe for another team to have access to all the data. So the next thing we are looking at here is fetching certain columns, right? We can fetch certain columns, and then we'll be looking at a different table. The first time we're looking at issue table, now we're looking at the consumer table. So we can do select, and we'll have date, and we'll have company, and we have tags, right? From my schema dot consumers. So in this case, we didn't put limit as well. So we only select certain columns, but we are not defining the rows, the number of rows we want to see. So we can do this. This is all it will pull out the date, the company, and then the tags. Now, if we want to use Control C now we have to use Control C to break out of this. Then we can run the same command, and then we include limits to limit the number of rows we want to see. Limit, and say 5. And we can see it here, the date, the company, and the tags. So not all of them has tag. It's just one for a particular date, right? So you can play around with the other columns as well, just to see how you can query them. And then there is what they call conditional clauses. Clauses are used to set condition. You want to query the database, or you want to query a particular table, but then the table you want to query has a condition tied to it. For instance, if you have a column named female, name sex, then or gender. If you have a column named gender, you can decide to now filter out maybe male or filter out only female. So for you to do that, you have to use clauses. Clauses are what you use to set those conditions. In this example here, we are going to look at how we are going to try to query the consumer table again, but this time around we are going to look at the column called consumer disputed, and I'm going to include that in our query so that you see. So I'm going to remove date, and consumer disputed. Okay, consumer disputed. Now, the date can also be there. It's just me that removed it. There's no uh any technical reason why I removed it. In fact, let me put it back so that we won't be confused. So we have date, we have consumer disputed, and we just want to fetch out the first five rows. And you see, the date is there. Consumer disputed, you are saying no, 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 no. It's actually no and yes, no or yes, right? So we are going to filter based on using the clause statement. We are going to filter out the yes, right? So how do we do that? We do select, right? Select, we have the date, that's the first column, consumer disputed second column, company third column, tags fourth column. From my schema.consumers, which is the table, we are limiting it to 5, right? But before the limit, we can decide to put the clause and say where is a clause. So we are using it to set condition. And then we said consumer disputed um said yes. So you can see that consumer disputed, we're now using the where clause. So we are using where to set condition on a particular column called consumer disputed. And then we are now looking at a particular value in that column, which is the yes. So when we do this, we can hit enter and you see that what it pulls is yes. Initially, what it pull is just general. There's no condition. There's no clause set on the first table. I'm talking about this table here. There's no clause set on this, right? But now we have included a clause called consumer um uh on the column called consumer disputed. So we now see that we pull the similar data, but then the consumer disputed is focused on yes, yes, yes. So that's it for clauses. You can use where in, we are still going to use it during the basic aggregation so that you have an idea of what we are talking about. So let's look at another example here. So we can also sort our data. Anytime you want to sort, you use order by. Order by is used for sorting. So what I meant by that is order by. So you use this to sort, and then you can decide to sort it in ascending order or descending order. If it's ascending order, you add ASC. If it's descending order, you add DESC, right? So the first example we're going to look at is to try to query the consumer table, set a clause that we are focusing on states that has what's it called, the abbreviation CA, and then we are going to order it by that state name. It, right? Without limit, you can set limit, but in this case, we are not setting limit. So select date, company, state name, consumer consent provided. That's the name of the table. Provided from my schema dot consumers, where state name CA, then we introduce the sorting keyword, which is order by. It can actually run in small letter, but it's good that you put your keywords in capital letter so that you can differentiate them from column names and other stuff. So order by, now you are ordering by what column? So you put state name, state name. So now this is how you sort. You've already know how to query certain columns. You already know how to include a clause to set condition. Now we are introducing sorting. So as part of your your instruction or as part of your code, you can introduce order by. You can introduce a sorting keyword, which is order by. But always remember that every time you are sorting, you have to sort by a particular column. So in this case, it's state name. So you hit enter, you see that this is CA, right? That's a lot, but let's see. The same command, we can put limit, um, limit 10. So we are limiting it to 10, 10, what's it called? 10, 10 rows. So we can also decide to sort by a different column, not just the state name. The same command, instead of sorting by state name, which is ordering it by the state name, we can decide to order it by the company, right? So you can see that we've ordered it by the company. We can see that it's now arranged starting from numbers down to letters. Now, one other thing we can still do here, which is you see by default it's in ascending order, right? If you look at this, by default it's in ascending order, looking at the company column. But we can do this again such that we can sort it in descending order. The same command, all we have to do is introduce this at the tail end, say DESC. So if we introduce that, oh, I think, yeah, there's a mistake. There's a mistake. Okay, yeah, it should come before the limit. So we can introduce this because once it orders, the next thing is to look for the command, which is to either arrange it as ascending or descending. So you can see that it now starts from Z. Right, from Z to X and then to W. So we sort in descending order. So we can sort in ascending order, we can sort in descending order. If we are sorting in ascending order, the keyword is ASC. If we are sorting in descending order, the keyword is DESC. Don't forget this. So yeah, basically this is all about sorting and what's it called? Sorting and how to fetch the table, how to look at some clauses like the where clause. Now, this should guide you foundationally to have a knowledge of how to sort and how to use a conditional clause. There is more that you will be doing in the advanced class. So this takes us to the next stage, which is basic aggregation, where we perform some foundational statistics like descriptive statistics and all that. But for this case, our data does not support this. So we are going to ingest another form of a new data. This data is called athlete events. So I'm also going to share it with you so that you can also do the same at your end. So it has enough information for you to play with, like sex, age, height, weight, team, and so the medals they won, the number of medals they won. So it's going to really be awesome. So the first thing we'll do is to create the table. So we'll do create table if not exists, right? And then it's still going to be under the same schema, my schema dot games. And then the next thing is to look at the ID. ID is an integer in this case. So we have name. Okay, I'll just leave it. Even though Postgres will change it to small letter later on, but let's stick to small letters. Name. Name is a varchar. By now you should know what a varchar is, and we can define the length. The length of the integer can also be defined, right? But I decide to leave it like that to the default. So The next thing is this sex also a virtual, meaning male or female, I guess. So if you're confused, I think it's ideal you open the file and have a look at it. Always feel free to do that. For instance, I'm going to go to my desktop and then I'm going to yeah, here it is, athlete event. So, let's wait. Let's wait. Let's wait. All right, here we go. So we can see this is the ID. This is the name. The sex is male or female. We have the age, the height, the NOC. I think it's talking about name of country. The games, that's the name of the game, which is like 1992 summer, 2012 summer, and so on. The year, the season. If you observe, you can see that from the games, you can tell the year and then you can also tell the season. So we have the city the game was played, the type of sport that was played there, the event, name of event, and then the medal, did they win any medal or not? So, and in this medal, I think we have the gold, we have the, what's it called, silver and bronze and so on. So let's quickly see how we can do this. So sex is virtual and then we're setting 255. And we have age. Age is an integer. We have height. Height is float. We have weight. Weight is also float. We have team. Team is a virtual. So please be very observant when you are doing this. The reason why I'm saying that is because most of you're not observant. You're not observant. You just go, you join the entire what's it called? Statement. You join them together, and then you now tell me it's not working. That's why I said watch it first, understand what you're saying before you start practicing. See how the commands were being typed, be observant, and then after that you can start. Some of you are actually good to be able to, follow it as I'm doing it, right? So that's not also a problem. But my concern is don't mix it up. So I have virtual for the games, which is also 255. And then we have the year, which is an int. And then we have the season, which is we'll say a varchar, which is 255. Then we have city, that's the name of the city, which is also a varchar. Okay. So I'm the one just setting them at this 255 is it mustn't necessarily be 255, right? It mustn't necessarily be 255. For instance, season. Season can be 150. It's just talking about the number of characters, nothing special about it. Okay. So don't be confused. And oh, okay, we still have some left. I thought we are done. We have sport. Sport is also a virtual, right? Then we have event. Like I said, be very observant. One mistake, the command will not work and you run into error. And sometimes the command on Postgres is not specific. You can be having a different issue and then it's pointing out a different issue. So you are the one that have to, check it out. Yeah. So this is it. We can have all these columns here. ID, name, sex, age, height, weight, team, NOC, which is name of country. You can, now that is actually not that, it's not ideal. It's not ideal. You can actually call it name of country, right? You're supposed to put it in full. So we have season, we have city, we have event, we have medal. Now the table is created. Okay, relation games already exist. Skipping. Oh, I think maybe I've created it before. Let me see. Okay. Mine missing something. Okay, let me see the schemas. Okay, let me try something. For you to tell me that it already exists. Oh, that was a mistake. Like I said, sometimes it can just be Postgres headache. It cannot specify the error directly. Okay, it already exists. I created it before. I didn't know. I thought not. So, but at least you could, see the walkthrough on how it should be created. But the table is empty. That's why you are seeing zero rows. So let's ingest the data into it. You have the backward slash copy. We're using the copy command to copy into my schema dot games. And then we have ID, we have name, we have sex, we have age, we have height. Don't forget any column. If you forget a column, it will throw an error. If you add an extra column, it will throw an error. Don't forget. Team, we have NOC, we have games again, we have year, we have season, we have city, we have sport, we have event, we have medal. So we are ingesting this from, we have to bring in our the directory where the file is located. This is it here, but you can decide to go to properties and then you get it from there. I used to, okay, yeah. This is it. This. Do not, the name of the file also has to be added to it, right? Let me see. Okay. I can put it here. Yeah. Oh, it has edited it. So let me just go back to the terminal and then paste it there. Oh, come on. Okay, just include backward slash. Backward slash. So the next thing I have to copy is this. So this one will also have to be bring this here, backward slash. So we have atlas events dot CSV, and then we'll put that. Then the next thing we'll do is based on our command. Based on our command, the next thing we'll do is to indicate the delimiter. Since it's a CSV, the delimiter is a comma. delimiter, and then comma, um, so CSV header. So yeah, this is basically it. So we are copying the CSV from this directory from the desktop, and we're bringing it into the table with these column names. And then we are specifying that it's a CSV, and the what is used to separate the data is a comma, the delimiter to separate each of those what's it called? Each of the each of the data in the CSV is a comma. So we hit enter. So we are having an issue with the column name with a value. So it's telling us that invalid input syntax for type double precision NA. So this is supposed to be context copy games line 4. Column height is NA. So column height is supposed to be we actually kind of specify that the column height should be a float. Now it's telling us that it's seeing a string in the column height called NA. So we can go there and check. True, they are here. So this shouldn't be. We can decide to make them empty. It is better that way instead of putting NA. And I think I introduced this myself so that when you run into this kind of error in a column that has numbers and then you see NA there, it's better you remove them completely or you replace them with zeros, right? Remove them completely or you replace them with zeros. So let me see, is there more? That's why we are having this one. So we're also having that. Okay, we're almost there. I cannot, okay, we can filter them, right? We can filter them and then remove all this. Okay, let's go and filter them because this data is actually much. So we'll not be able to keep up. So I'm going to try and filter it. The one I will share with you is going to be the clean one. So don't worry. Don't try to, you know, do the same thing so that you don't get to stress yourself. Um, yeah, NA. So this is the NA, and let me focus on the one I filter here. So these ones have no age. Is it age or height? I think I've forgotten the column. It should be height. But this is not actually true. Um, okay, we don't have this time. So I'm just going to delete it. And then I will select all this back and then go to weight as well. Select the NA. So here we also have, then go to the age. And then also select, and then we do this. So yeah, we are good. So let me save this. Yeah, so I've saved it. So I'm going to run the same command again to, ingest the data. So to copy it. Now you can see that the record has been copied. The record has been copied. So one of the things I want you to note here now is that you can't have a string mixed with you can't have what's it called? Alphabet or string mixed with numbers, Postgres reject it during ingestion because it's going to ingest the data based on their data type. So you have to ensure that you correct that. But I mean, this is just for you to have an idea. It doesn't mean that this is how your database, there's no database that is this way, right? So the software engineer will make sure that during the design, they don't make this kind of mistake. So there's no way that will happen. Then we'll go to the next thing, which is for us to work on basic descriptive statistics. So, I mean, the first thing we should do is we can actually select some columns and do a count. A count now will do the number of medals that have been won by each team. So, and then we can use the AS. The AS is is it called is aliases or aliases or aliases. Just manage it, whichever one you prefer to call it. Right. The AS is aliases just to like rename the column. I'll show you what I meant by that. So we can do a select. We select team, and then we select how many medals does the team has. That's a count. This is a window function, but we'll talk about window function in advanced classes. For now, just know that there's a method called, there's a keyword called count, and you can use that keyword to count, to do a count on your, what's it called, on your table. So we are going to count how many medal the team has, and then if we do not rename it, let me show you what will happen. So you say from my schema dot games, right? So, but before this count will be effective, we have to use group by. Group by helps us to group the team. So if you don't group by team, the count will not be effective. So you need to group by team because you know the team kind of appear repetitively. Some team appear more than once. So you have to group such team before you can then count on that team. Okay. So we have this, and we can now say limit just shows the first 10 rows. So you can do this. You see what we have here? You have the team, and then you have the count of their medals. But then we don't want this to just be count, right? We can rename it, and that is where the AS comes in, which is the alias. You can say AS, and then you can now say maybe number of medals, number of medals. So you can see you with the AS, you rename it instead of it to be count. You know, it's count here because we didn't use AS. But now with AS, we have renamed the count into number of medals. Then you have this. So uh another thing we can do, remember we can sort, right? We can sort. We can sort by the number of medals. If you remember, we talked about sorting earlier. So let's look at this example on sorting. Select team, and then count medal, AS, medals. We can call it medals or we can call it number of medals, but I prefer number of medals. It makes more sense than to just say medals. Number of medals or count of medals. So you say from uh my schema dot games group by the team, and then we do order by. So now we want to order by number of medals. Okay. So you use the column, the new column name you gave to it, number of medals. That's what you're going to use, medals. And yeah, you can do limits. Let's not do ascending or descending. You can do limits 10. So we'll show the first 10 rows. So it's going to be in ascending order. Remember, I told you earlier that it's by default it's in ascending order. So you are now the one that have to specify if you want to look at it in descending order. So you can do the same thing and then come here and then put DSC. That's for descending. So you can look at this from descending order. Also, okay, you can see this is in descending order right now. So you can sort by the number of medals. You can sort by the team if you want to. It all depends on what you are doing. From here now, your analysis is showing that United States, the number of medals they've won, France, the number of medals they've won, and so on and so forth. And we can also move into working on, using a frequency table. A frequency table helps to show, just kind of like the frequency of or the count of what you have. All right. So basically, what you do here is a frequency table. What we've been doing since is a typical example of a frequency table, right? So when you see count, like number of medals, that's a frequency, right? But then just to play around here, I can still work on this example, medals. And next thing is count. Count, we have medal. And we can do from my schema dot games group by medal. So it's just kind of like to show the frequency. You can see it's similar to what you have here. It's just that this one is medal. You are looking at what's the frequency for each of those medals, the bronze, the gold, the silver, what's their frequency. The same thing for team. You can tell the number of medals for each team. All right. So another thing we can look at here, I think we've done an example on this. Yeah, we've done an example on this. So we've looked at how we can sort by the number of medals. We can also sort by the team name and so on and so forth. So let's look at another example. Here we are talking about descriptive statistics, even though what we've been doing since is also an example of descriptive statistics. So we can do a count. We can do what's it called? Uh we can do a count. Yeah, we can also apply the where clauses, right? So these other ones you have here, you can play around with them just to get yourself around it for you to be able to know how to, run some of those commands. But let's see how we can introduce a clause here. So one of the places we can introduce a clause, the last command we ran, we say select medal, count the number of medal, and then group by medal. We are grouping because bronze can appear several times, gold can appear several times, so we have to group it now so that we can have them to be unique. So we can have the total number of bronze, total number of gold, total number of silver. So what I wanted to do here now is that I want to filter, the where clause, we use it as a condition. So we can have the count, we can use our aliases AS to be number of medals, right? And then from my schema, can group by medal. So the next thing I wanted to show us is introduce the where clause, where, and then what's the name of the column we are looking at, medal. So where medal is equal to gold. So we want to filter out only gold, right? So we can do this. So if you run it, we're running into error. Why? Okay, let me see. I think it's just an issue with okay. The issue is just the order of priority. You can say where medal is equal to gold. Okay. Yeah. So group by medal. This shouldn't be, yeah, this should run. So one of the thing I would like to get your attention to here is that every time you are running the where clause, you're using the where, which is for the condition to set the condition. Always make sure that it comes before the group by, because if it doesn't come before the group by, you may run into error. So basically what Postgres is telling you here now is that first you have to carry out your condition before you now started running your grouping. Okay. So yeah, let me see if there's other example here. I don't think. Okay, this is to ingest the data. Yeah. So yeah, there are other examples here anyways. There are other examples. So let's quickly take a look at them. So we can do a minimum, we can do a maximum. In PostgreSQL, the minimum is called min. The keyword is min. Then for maximum, the keyword is max. And for average, the keyword is avg. So we can actually run some of those queries, right? All we have to do is that select. So we are now saying select the minimum age, and also select the maximum age. In fact, let's do this. Let's just select the minimum age. Nothing more, nothing less. Select the minimum age from my schema. There's a reason why I'm doing that, so that you can really, let me not rush you into it. From my schema.games, right? Can do this. You can see the minimum age is 10, right? So we can also do for the maximum age, the oldest person that has ever played in the game, maximum age. Maximum age is 97, right? I hope that guy is not from Japan. They are the one that used to have this kind of lengthy age still participating in sport. So now we can actually run the same thing, and then we can also run the average age that has played in the game, right? Average age is AVG, and then the average age is what? Is 25 years, right? That's the average age that has ever run. So this is just to give you an idea of all this, but we can put everything together. We can now say, okay, select from the minimum age, and then we name it. We rename the column. We rename it when we show this thing as minimum age, minimum age, right? And then we can also do max age as maximum age, maximum age. And then we can also do, what is it? The next one is average age. Can do average age as, can do average age as, so we rename the column as well, average age. So from my schema tables and so on and so forth. So what we are now doing now is that we are looking at the entire data set. We are computing the minimum age, the maximum age, the average age. All right. So we can now see. So everything we did individually here, we did them together. Now we have the minimum age, we have the maximum age, and then we have the average age. All right. So basically, that is what that is all about. And the other one we can have here is we can decide to work on the team, right? We can decide to look at each team, the minimum age, the maximum age, the average age per team. We've looked at it generally. Now, in statistics, I've forgotten what they call this. I'm trying to remember. Sometimes it's called something paradox. Forgotten what they call this paradox. So what the theory is basically saying is that when you look at a group of data, there may be a hidden information. So that sometimes what you have to do is split the data and then, carry out the same analysis on the splitted data that you may find more information that is hidden there. Is this Simpson paradox? I've forgotten what they call it. So the same thing we are trying to do here. We've looked at the overall. We've looked at the overall minimum age, maximum age, average age. Now we are going to look at the team. So we look at each team. So we say team, and then um remember team can reoccur. So we have to group by team, and then we can set a limit, right? We can set a limit, maybe 10. So basically what we are now doing, we are doing the same thing, but now at team level. So for each team, what age is their youngest age, their maximum age, or their oldest age, and the average age that each team has always present every year. So we look at it. You see what we have here. So for each team, this is what we have. So you can see that like the Albanian people, the Albanian has they feed in almost the same, the average age that is the general average age is what they also have as their own average age. But you cannot say of that of Alien 4. Alien 4 has their average age to be 48. That means they always feed in very old people. Or let me say, no, not very old people. People in their mid-age, like 40, the youngest is 40, the oldest is 54, right? So we can also sort this, right? We can sort it and do ascending and do descending. We can sort it by the team, right? We can sort by the team. Let's say order by. Remember when we want to sort, we do order by team, and then we can put descending. Okay. So you can do this. You go and look at the teams at the bottom. Look at the teams at the bottom. So you can also sort by the minimum age, maximum age, average age. You can sort by whichever way you want to. So in fact, let's sort by the average age. Let's see which country has the highest average age. So you can come here and say order by the average age, right? And in descending order. So this will help us to see the countries that have the average age. Okay. Let me just pause. Uh, so, in order to round this up, so we can also sort by the average age and in descending order, right? So you hit this and okay, I sort by the average age in descending order. Uh, I am not, why is it empty? It shouldn't be. Let me see. Average age. It shouldn't be ordered by average age. Okay, let me just see. Let's see for ascending. Let's see. It has something for ascending. For descending, it shouldn't be empty. That's strange. I don't know why it's empty, but because I believe there are those that have high number of average age there. But then that would be it for this one. So you can, play around with it and get yourself familiar with it. Uh, yeah, I'm going to send you guys some exercise to play with this particular data set, which is this, what's it called? The games data set, right? So one last thing we should quickly look at is the operators. So operators also are similar to uh, SQL clauses, but then they kind of like they differ a little. With operators, we can set we use operators in like a complementary tool with clauses to make our statement more uh, rich or elaborate, right? So basically what I'm saying is that when you bring in statements, you'll be able to, when you bring in where clause condition, remember that where clause condition, every time we're using the where, we have to set condition. Now, those condition requires operators. The operators, we can use them to now set what we want to do, right? Now, let me just give you a simple example so that you understand what I'm saying before we call it a day here. So we can select ID, team, age, from. So we are selecting these three columns, ID, team, and age, from my schema dot games, right? And then remember we've used where clauses before. You should be familiar with it now. We are now saying we're using where clause, and then we are selecting a particular column that we want to carry out a condition on. We say height. But then this height we are saying, remember we are now dealing with numerics. We are no longer dealing with strings like words. Before we are dealing with words, we are saying where gender is either male or female, and so on and so forth. But here now we have switched a little. We are dealing with numerics, and then we are now saying where height is null. Null meaning that that particular value is empty. There's nothing there, right? So now we can use the null command. But what I want you to be sensitive to is the operator we are using. We've been using it since, it's just that you were not observant. The equal sign is an operator. It's called an SQL, is one of the varieties of SQL operator. So we are saying under the height column, anyone that you see that is empty, filter them out. Okay. So you see, it's telling us no. Let me see. I think let me put this as a string. Yeah, this is an error. Okay, because it's expecting double precision. So I'm trying to figure out like those ones that are empty should be displayed, right? So let's say I did this. Let me see what it does. It's expecting a value. So it should be null by default, but I don't know why it's not null. It should be null. Ideally, it should be null. When you put null, it should filter out those ones that are empty. But it's telling us that, okay. I think I know where the issue is coming from. Height is not part of what we are displaying here, right? So we can actually add height to the columns we want to show. Height. So when we do this, where the height is empty, right? And then we can also do for weight, where the weight is empty. So we don't have the rows here, but then I think there are rows that are actually empty. It's just that how do I put this? It's just that it's not sensing them as null. It may be sensing them as something else. Though I didn't put this, but let me see. Yeah, there's none that are 0, so you can't return it. So let me see if, yeah, there is none that is 0. Remember that height and weight, we set them to be float. So the null keyword is actually supposed to filter out, is supposed to is used to replace those values that are empty in a particular row, right, or column. So one of the things we can also do here is, just as we have if height is equal to null, we can also have if height is not equal to null. So in this case, what you will do is this is not equal to the arrow key, left and right arrow key joined together are used, or is it elbow or arrow? I don't know what they're called. The left and the right arrow, put them together, that is not equal to. It's representing not equal to. Let me quickly show you something here, because I may assume that you understand what I'm saying, but you don't. So equal sign, this is an operator, right? Is the equal sign. We'll be using it with the where condition or where clause sense. Now, when we want to have not equal to, what you do is you use this arrow key together. That is not equal to. So this is equal, right? This is equals to, this is equals to, and then this is not equal to. Okay. So, but then we cannot type not equal to, because Postgres is sensitive to certain command, not equals to. So this means not equal to, this means equals to. So now I want to show you another example. Even though this example is not what I expect it to be, I may change it before I send you the slide, right? So another way to do this equal and not equal to is to use the is null or is not null. This also is an example of equal and not equal to. But I'm going to quickly show you another example right now. And that one will be, just a second, let me think around this. Team, right? Maybe some team don't have a name. That should not be. Or let's say the medal. The medal is actually something we should look at. So let's look at the medal instead of here height. So where the medal is, where medal is equal to NA. Nothing like that. Okay, let me just think. I'm thinking of an example we should look at. So let me look at the entire data set so that we can have an idea of which example to look at. My schema dot games, and then we set the limit to be 10. I hope I'm audible enough, but if I'm not, so I'm looking at where we can have something reasonable to work with. City, there must always be something that, let me look at the column names. Sport, team, sports, event, season. I'm looking at something we can use for this example proper. We have height, weight, team, sport, Netherlands. Let me see. Let me rerun this command and then put 100. Maybe I could find something that can be useful. So all the countries are there. All the countries are there. Just a second. All the countries are there. I'm just thinking of the possibility to have the one that has an empty cell. That's what I'm looking for. Mm, okay, if I can't find it, we'll just use the NA for an example of what I'm referring to. So let's look at though the NA here is seeing this as a string because actually it is a string. You see, if we pull it out, it's a string. Those ones that is not applicable, right? What I meant by that is NA, let's put limit so that we can look at it properly. Limit 10, limit 10. So we've selected the ID, the team, and the age for those ones where the medal is NA, like they didn't win any medal, not gold, not silver, or bronze. Then we can run the same command instead of using this one. We can run the same command now, not equal to. See, now these ones now they actually won medals, right? How did we know they won medal? Because where we the column for the medal we are now filtering out where there is no NA. That's what we are doing. So we know that these guys, they actually won medal. Now we can do the same thing using, what's it called, is using the is command. Say is NA. We can do this. Oh, okay. It's null, it's not null. I think it will not work for this because of something. Uh, yeah, because of this. So this operator, which is, we can actually use it for, okay, I think we can use it for age. Let me do age, where age is not, is, let's say age is 30. Can do this. No, it should work. Should work. I don't know why it's throwing an error. Mm, okay. I'm thinking of an example that will work for this because the is and is not is also an operator like, but the only difference between this operator is from the equal sign. The only difference is that this one is more sensitive, while this one can be used like generally, and then this is the opposite of the equal, which is not equal. We now have the is. The is more of like a Boolean, right? So the is and the is not, they are more of like a Boolean, trying to check any value that matches a particular value they are looking for. For instance, any value that matches this null or that matches null or that does not match null. That's what the is not is for. But then I will share you an article that will guide you better on this SQL operator so that you can play with it. But I'll also update this example and share more example with you on this so that you can also um, find your way around this. So the next this thing we'll do, the next class we'll do, it will be a short one, like maybe 30 minutes. It's going to cover the join, how to join tables, inner join, left join, right join. Okay, so we'll stop here and then I will share these ones with you. All right, thank you for your time.